question is what is Hellenistic astronomy? And the second question is what is the relationship between astronomy on one hand and the
Hmm.
society on the other?
The first question is, the answer is Hellenistic astronomy is the astronomy in ancient Greek from about 600 BC to the start of Common Era.
Right.
And that is the period when a lot of things happened, a lot of discoveries were made, a lot of good, excellent scholars were there. But actually later what happened, all that information or knowledge got stored in Arab, and it got lost because the the what I'll say, the Greek civilization, Roman Empire, they're all gone. So period, about 600 years, 700 years, when the Greek astronomers were very active and made many excellent contributions, that period is called the Hellenistic.
Right.
So you can say almost from about 600 BC to approximately the first or second centuries Common Era. The second thing, the link between astronomy and society is one topic which we will discuss today. It is there.
Okay.
So I think the students who have the question, they will get their answer from. Now, this is the slide where we stopped in the last lecture, where we are saying that in the astronomy had an importance in the construction of major structures, very major structures like Egypt, etc. Because obviously, such a huge thing, people will not want to put in a very haphazard way. So the most obvious choice is to be the cardinal directions, which are linked with the concurrent astronomical directions, exact north, east, west, like that. That's why this, and uh, therefore, I think you can, by studying the structure, you can say that if there is a misalignment now, then you can see that why this misalignment has taken place and how much time it has taken. Now, this is a kind of thing which has been used to date the major pyramids, and we will just discuss that by a lady astronomer from England. It was very well appreciated. Now, in ancient India, there was no tradition of constructing major structure in memory of kings, queens, and other important persons. Actually, structure started after the Buddhist era for constructing stupas, which used to be the storehouse or the storing the relics of Buddha. That's what it is said. Before that, you won't find any major structure. And Megasthenes has written when he visited Pataliputra and spent some time, few years. He wrote in his memoir on ancient India, that is Indica, on the 3rd century BC, that in ancient India, it was believed that a person was remembered after his or her death because of the good work done. So this is a very important statement, you can see, and it was by whom? By Megasthenes. Now, 3rd century, 4th century BC is already an ancient thing for us, but for him it was contemporary because he was visiting India. And he has mentioned in his memoir that it was not the custom to build major structures in memory of kings, queens, and the concept was that they will be remembered, people can be remembered after their death because of their good work. Very matured philosophy, you must recognize that. But we had that, as I mentioned, we have a unique wealth. We may not have huge structures, etc., but we have a huge body of ancient scriptures and literatures rich in astronomical description, which is again unparalleled. Nowhere in India, in no civilization, you have such huge amount of literature, ancient literature, that everybody accepts. Over and above that, the positional astronomy in ancient India was very well developed and matured. Therefore, the descriptions of ancient star alignments and their arrangements in the celestial sphere are quite significant. Above all, astronomical observation and its recording played a very significant role in the daily household activities. The pujas, the rituals, these, that, everything. Even today, anything you do, the old timers will say, okay, পাঁজিটা কোথায় দেখি, হ্যাঁ, কোন সময় হবে, এখনো যে আপনারা দুর্গাপুজো করেন, the puja, etc. That is all that tithi, etc. based on astronomical alignments. So you see that it is even continuing today. Now many texts again, like Mahabharata, like epics, contain a large amount of description of various astronomical phenomena, many of which can be very useful for application of descriptive archaeoastronomy, which will be a major point of discussion. Of course, you can realize that the astronomy was a naked eye astronomy in those days. And obviously, the accuracy is somewhat questionable. But what we can get a good idea about the era around which that description was made, not the date or month. For fixing the date and month, normally there are some special cases like very specialized or special types of eclipses that can pinpoint dates. But other things like the position of the equinox, etc., that there will be always an error of about plus minus couple of hundred years. So this way, the scientifically we can have a time frame of ancient India, particularly the protohistoric period. And this is something which we will do. Of course, the date we or the era or the chronology we develop, it has to match with other observations also.
Sir, one question. What is proto-historic period, when it starts and when it ends?
Okay. Protohistoric period is that. Prehistory is when, we have only some artifacts like stone tools, etc., all those things, nothing else, like our Paleolithic, Neolithic, not fully Chalcolithic. Chalcolithic was a part of it is in the protohistory. Protohistoric period is that part where we have a lot of information in the form of diagrams, scripts, but they are not deciphered like in the script. But there are such things. So that period is called protohistoric period. Now, as I mentioned, that in the case of India, the importance of establishing the correct history of her past is more important as it is still shrouded in mystery and is full of controversies. I explained why. Because our information got lost. It was recovered by the European scholars in the 17th, 18th, 19th century, particularly 18th and 19th. But I think because of many reasons, there were some wrong decisions or opinion, or rather wrong suggestions about the ancient India's history, which we are still continuing because that is the beginning of studying ancient Indian history. So we will discuss all those things. Say Max Muller attempted to date the most ancient text of the world, that is called Rig Veda. He gave some ad hoc decisions based on a number of unsound assumptions, and at a later time, he himself withdrew his suggestions that Rig Veda is 32 years old. This again he related to a proposed hypothesis suggesting that there was an invasion by Western race termed as Aryan, and it was taken for granted that India's civilization was brought by these people. However, the scenario got completely transformed after the discovery of the Indus Valley cities, which were estimated to be more than 4,000 years old. Even the late Harappan period is pretty old. Subsequently, a huge amount of investigation has shown that I will come to that later. Now, an erroneous dating of the Rig Veda by Max Muller and the concept of Aryan invasion theory by him, that has introduced enormous aberration in the history of India, resulting in a large number of controversies and mysteries. It very clearly indicates how important it is to establish a correct chronological order. Without correct estimates of the antiquity of various phases of the past history of India, it will not be possible to form a correct picture of the progress of civilization. Again, Indian subcontinent, it lies in the tropical region, we have a monsoon, a lot of rain, it is warm, humid, and that kind of a climate is not very suitable for sustaining all forms of, or that means to preserving the ancient things. Like Egypt pyramids, because of their arid zone kind of climate, they have not been, rather, I'll say not destroyed, not been affected so much by the climate. But in India, it is a very different situation. Now, because of the temperate climate also, and abundance of water, plant and animal life, it is expected that it is very suitable location for civilization to flourish. However, at the same time, as I just mentioned, the tropical climate does not permit preservation of ancient objects, and all evidences of ancient structures decay with time unless these are made of stone or very similar durable material, like terracotta, but which is a very modern thing. Terracotta is not ancient. This is another problem in India, that preservation of the ancient, whatever ancient objects you could consider, though it is not possible because of the very climate which is very suitable for life, but not very suitable for preserving things. Now, I think as this is the question which some of your students asked and which we'll discuss, that influence of astronomy on society. That is the question you said. Now, what is the link between and what is the connection or relationship? Now, the dawn of civilization, mankind has remained fascinated by the star-filled sky. Obviously, you can see that every night you have nothing to do, because in those days, activities at night was not possible. The only thing which they could see, they used to wonder, oh my God, what is there? All these bright dots of lights, and they're moving, going from one direction to the other, which we call east and west. Then there is a big, bright object, which also is there, which is much brighter and bigger than the other dots. And it also changes its shape over a period. And and again, they found that after half a day kind of thing, which they consider the most bright thing, sun rises and all the things are obliterated and they vanish. So it is definitely an extremely interesting thing to observe, and that they did. And the shape of the moon, it changes in a very regular way, we all know that. So that gave the idea, or that helped them to develop a month kind of concept. And daily rising of the sun became the most important factor. There was one period they used to call day, and the one complete period of a cycle of lunar shape change they used to call month. And this changing phase of the moon became one of the obvious markers for keeping the track of day. Now, this has been followed by many tribal societies and is followed even in the present times. Man also observed some connection of the. Now you see, they noticed that there is a connection between the heaven and the earth. Like when it is full moon or new moon, the tide is much stronger. Those who used to live in the coastal areas or near the estuaries of big rivers, they saw that. And again they found it. So they thought, oh, there is a link between that. Then, so the shape of the moon was linked with the strength of the tide. Then again, one thing throughout the world, what happened, all the women, they had a period which they found very interestingly that it matched with the lunar month approximately. That is another thing which they found out. The human body is also then connected with the heaven. And of course, there are other things at a later time. They found that when sun is at this particular sign, it is very hot here. But when it is there, it is cold here. So, but those things now we understand very easily using the physics and astronomy. But they thought it is a kind of influence of the heaven on the earth. Actually, that is something which led to something which, in my opinion, is a non-science, that is astrology. I personally think that it is these kinds of things which has resulted in a topic like astrology, that, the alignments of the stars, these, that, planets, they affect our life, like that the marriage of the daughter or the curing of a disease, all those things, kind of thing. Now, this also that led to a belief that the heavens have a close link with the affairs of, actually, I'll just digress here. Uh, after some astronomers, they could then also at a later time predict certain phenomena like eclipse, etc. And the kings in those days used to be very superstitious, I must say. They used to say, if I go and invade my neighbor, whether I will win the war, etc. And they used to then tell that, okay, you can predict eclipse, etc. Can you predict that? So actually, ultimately, most of the court astronomers became astrologers. And you will be interested in knowing that Kepler, whom we consider as one of the greatest astronomers of our history, he is earning livelihood used to be from the prediction of these kinds of astrological predictions in the court. So therefore, the livelihood is to come from something like astrology. But to do astrology, they had to practice astronomy to predict these, that, all those things. Actually, that's why many say it is astrology which was the motivating force for doing research in astronomy, which is very strange, but it is true. Now you see that, as I mentioned, that uh, major examples like pyramids in Egypt and Central America, there are lots of pyramids, and they all were having some kind of astronomical alignments and some link with the heaven. Even the prehistoric, we all are familiar with this. The prehistoric structures like they call megaliths. It was in the proto-historic period that when the society, they wanted to keep track of certain things which they had to depend on astronomy. Like say, it's summer solstice day when the day is longest, when the day is shortest. That they used to do with the help of making some stone structures. In India also you have huge number of such aligned stone systems or megaliths. This megalith, they used to, I'll show you one of the most famous megalith is the Stonehenge. These megalithic structures used to tell that what is the longest day, what is the shortest day, etc., all these kinds of things. Now, this map, these are the sites where megalithic stone arrangements have been discovered. Many of the prehistoric megalith sites show stone alignments to determine the cardinal days during a year. Cardinal days are which? The longest day, shortest day, day and night equal, equinoctial days. These are the 4 cardinal days. In some sites, the evidence exists that observation of the rising and setting moons was also made. A lot of analysis has been done. Not that all of those are correct, but it is found that rising and setting these positions that played a very important role. The distribution of ancient megalithic monuments in Europe is shown here. And India, we had a very large number of megalithic arrangements throughout India, distributed from northeast to south. And there is a separate book also in my I have in my library. As an example, the megalithic monument, Stonehenge is being briefly discussed here because that is the most famous one and most well studied. Among the large number of ancient megalithic monuments discovered, the most famous one is at Salisbury Plain in the Wiltshire district of England. It is famously named as the Stonehenge. Now, the figure, this is the plan of the Stonehenge. You can see that the stone blocks, they have been arranged in the form of a circle. And it has been studied, not that everything was very scientifically done, but there are certain things which was very clear. Say, for example, the direction in which sun rises on the summer solstice day, etc. That and some stone arrangements are there, and people have studied. There has been over enthusiastic studies also bringing many things, but more or less it has been found that only the solstitial days, equinoctial days, etc., and rising and setting of the moon, etc., could be somehow linked with the location and the arrangement of the stone pieces. These stone pieces are pretty big. Some of these stone pieces are almost 7 to 8 meters in length, right? This is the stone arrangement. The alignment with the sun at summer solstice is reasonably visible. You can see that this figure of sunrise, it was on the summer solstice day. But many other astronomical alignments which the researchers have found out are somewhat speculative and debatable. Only these cardinal days you could link the arrangement of the stones. Now, this is another important thing. When it was built about 4,500 years ago, now you know that Earth's axis, which is tilted at 23.5 degrees at present with the ecliptic plane, these things will be clear when you discuss positional astronomy. But that is not a constant, it also varies. And the period is about almost 40,000 years. But it varies a little bit, about 1.5 degrees this way, that. So, and 4,500 years ago, the Earth's axis tilt was almost 24 degrees instead of the present 23.5 degrees. Now, this tilt affect the location of the sunrise on a particular solstice day, etc. So, the azimuth of the summer solstice was 50.5 degrees instead of the current value of 49.55. So, it is about just 1 degree. But this 1 degree can be used to identify approximately that is the way it has been founded how old this Stonehenge structure is. So, the present, this is one thing I must mention at this stage, that the location of the sunrise on particular cardinal days, they depend only on the tilt of the Earth's axis, not on the precision of the equinox. Therefore, this is not very helpful in developing a chronology, because the location of the sunrise sunset on particular cardinal days, they don't change with era. Even for thousands of years, they'll be the same. Little bit of variation now, only because of the Earth's axis still is slowly varying little bit, but not much. So, a major effort has gone in studying the alignments with reference to the directions of the rising and setting of sun on the cardinal days, and sometimes also of the moon and its rising and setting position. A large number of temples in Egypt have been found to be aligned, keeping the astronomical objects in mind. Ancient burials have also been studied by archaeologists to find out statistically relevant issues in their alignments. Generally, in majority of such cases, the objective had been to investigate the socio-cultural customs practiced by the ancient people. So here, you have to keep that in mind, that this kind of physical archaeoastronomy, that means which depends on the study of the physical alignment, etc., of the structure, that didn't help much in developing a chronology, but it was primarily with the aim of studying the social customs, etc., prevalent in those days. And that is the purpose for which the physical archaeoastronomy has been used so. As I mentioned, the directions of rising and setting of the sun and the moon, they don't change because the tilt of the Earth's axis is more or less constant. So these structures do not help much in establishing chronology. However, the major pyramids in Egypt have played an important role. There has been some important observation which I just mentioned. And among the interesting studies on the alignments of these major pyramids that conducted by Kate Spence, a PhD researcher at Cambridge University, and it is worth mentioning here. The accurate dating of the pyramids can be done by studying and analyzing the precision of the two stars, Kochab. You can see Kochab is, this is the Little Dipper, uh, Ursa Minor, and this star is called Kochab. This is the true celestial north point. Now, what is true celestial north point? And where the Earth's spin axis meets the celestial dome. There may be a star there, there may not be a star. This is the great pair, that is Saptarshimandal. Now, it was actually in those days, if you join at this, when they are just a median time, that is their vertical, that time joining Kochab and Mizar, that used to pass through the true celestial North Pole. And this methodology of joining Kochab with Mizar, and when they are vertical, and that direction considered as the true north, this was followed for constructing the major pyramid. But remember, there need not have been any star here. But when I think the major pyramid was constructed, there was a star which we call Tuban. That was the pole star of those days, which is also described in our Vedas and others. So that was followed. But with time, what happened? The stellar alignments changed, and the above method does not yield correct direction. But if the same procedure is followed, the result will be erroneous. And this error has been used by this researcher to date the construction of this pyramid. You see, if you the present position current, I found this sky map. This is the pole star currently, which is the true north. But if you join Kochab and Mizar, and when they are vertical line, you find that so much of error, almost 7.5 degrees. So this is that point you can see that if the same method is followed, you will not have correct orientation. And this was done by the researcher. You can see here. That means how many years before Common Era, the 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 various pyramids were constructed. That was done by considering their error from the true north, like 0. This is the error from the north, true north, in arc minutes. So here it was about only maybe 3-4 arc minutes, but later it was more, and it has started increasing because, as I said, that the star alignment changes, and this line no longer passes through the real true celestial north. So what Kate did, she used this error and developed a chronology of the construction of the pyramids. Like, as time progresses, you can see, as time progresses, the error becomes more and more and more. Other thing is that it was found that the pyramids have some shafts. Originally, it was thought that these shafts are for ventilation purpose, which goes to the inner chamber or vault. So, there is one, but later it has been found that they are actually connected with some major star. Very important star in Egyptian ancient time was Orion, that constellation. And most important star was what you call Sirius. Look down. That's the brightest star. So it has found that Khufu pyramid, the stellar alignments, that this shaft was exactly aligned with this Sirius, but not now. So, but it is only for modern analysis they found that in 2550 BCE, this shaft was constructed so that the light of Sirius could go directly reach this wall. Similarly, here, the upper southern shaft, this is the belt of the Orion, and this star is to be visible from here. And the Tuban, the pole star, in those days, there was a faint star, which is pole star, that is to be visible from this. And all these things are possible at 1550. So you can see that the study of the association of various stellar alignments or arrangements with the features of these major structures can tell you that approximately what time these things were done. Here, luckily, we have the record when this date, a Cuckoo's time, so it was possible to do this calculation. It was found that they match very well. So that's how this is the kind of thing which people do in physical astronomy. But the scope is very limited because not many ancient structures like this are there. Now, unlike physical archaeoastronomy, descriptive archaeoastronomy does not require any physical structure to study antiquity. And descriptive archaeoastronomy is a subject where an ancient description of stellar alignment in the sky is studied and in many cases indicates the antiquity. There are primarily three types of descriptive archaeoastronomy as mentioned below. Analysis of stellar alignment, like the location of north celestial pole, the occurrence of simultaneous transits of major stars. Transit means what, which is vertically above, we call the vertical meridian, which is just above it. Now, many descriptions are there which describes that some major stars used to cross that simultaneously. You will find that Rohini's, there are many such legends are there. That is one phenomena which can be used for dating. The location of the equinoctial points among the nakshatras. Equinoctial point means what? The point where on the ecliptic, where sun is there when day and night are equal. There are two such, we will see that all those details later, but I'm just giving an overview now. So one is in the spring, other is in the autumn. Now that position, that it is not a real physical position, but a geometric point. So that shifts with time slowly because of the precision of the equinox. And that also was indicated indirectly, that means which nakshatra is to rise exactly in the east, etc., which we will go and study in details later. You will find very interesting. And this also includes, actually another thing is to be there, that the sages and many other scholars, there is a habit of going, rising very early in the morning, Brahma Muhurta, and going to some stream or major tanks or lakes and offering pujas, etc., looking towards east when the sun rises. So you know that there are certain things that before when the sun rises, just before that, when it becomes again bright and stars vanish, there are certain stars and constellations which you can see rising and then vanishing because of the sun coming behind. So that is called heliacal rising. That used to be also a very important observation, and they have noted all these things. And that also changes with time. Then there are some spectacular events like total or solar eclipses on very specific and special days of a year. And analysis of that can give a more accurate, more pinpointed date in that. That a lot of research has been done on a particular eclipse which has been mentioned not only in the Rig Veda but in some other Vedas. And I will come to that later. I will show you that the Sengupta, who was a very famous astronomer, a professor of astronomy in Calcutta University. He did research in 1945. It was published in Harvard Journal. Now, India, as I mentioned, enjoys a unique advantage in the matter where we have a huge amount of ancient literature. I think now we come to the point that why you are studying this ancient Indian astronomy. Now, to make use of all this information, now we have to have some idea about the basics of the positional astronomy and the basic structure of ancient Indian astronomy. Because when some ancient somebody writes something, it is based upon the concurrent astronomical astronomical subject, that they will give that description. Now, if we are not familiar with that what was the astronomy practice in those days, it will be difficult to apply that knowledge in finding the dates and antiquity. Now, this course will therefore present these topics, and finally, an attempt will be made to use the technique of archaeoastronomy, descriptive archaeoastronomy, to develop a tentative chronology of ancient India, particularly the protohistoric. Historic period, there are many written documents, etc. We need not depend so much on astronomy. Now, the large number of astronomical references which are found in the vast body of ancient Indian literature can be understood and analyzed if and only if one understands the ancient astronomy developed in India. It should be remembered that the astronomical science prevalent in ancient India was different from the system followed now. As the application of astronomical principle of establishing chronology requires correct interpretation of the ancient references, it is also important to find out what is the correlation between the ancient names and current names. Suppose a star or constellation, what they called 3,000 years back and what we are calling that star now. That is also very important. This is another important thing which we have not discussed, but we have touched upon. The lost ancient knowledge and the wisdom, which I think Professor Chakraborty was mentioning that why it was lost and all those things. Now, our subcontinent was the cradle of one of the most ancient civilizations. Actually, all scholars throughout the world, they agree that this is the oldest continuing civilization of the world. There are other ancient civilizations there were, but they are not existing anymore. But as it happens with other branches of scholarly activities, astronomical knowledge remained confined to a small group of people representing the academic world and Sanskrit. Subsequently, India experienced a series of invasions from outside. Some of them, they were absorbed into our society, like the Shaks and Huns. Even you know that Kalidasa himself was a Shak. There was no problem. But at a later time, uh, when the Islamic world started invading India, those rulers were not interested in the ancient knowledge and they didn't get absorbed in our ancient society. They remained as a that we see even today also. Now, for about 800 years, the Islamic rulers did not bother either to preserve or to practice the ancient knowledge. And a large amount of that ancient knowledge got. As a result, the ancient Indian astronomy was also forgotten till India came under the influence of European rulers from the 17th and 18th century. Only after the arrival of European scholars, ancient Indian knowledge system started getting attention and many of the things were rediscovered. And how ancient Indian knowledge about astronomy was rediscovered is an interesting story. The story of the rediscovery of ancient Indian astronomy, how it was rediscovered, is very interesting. Actually, in those days, the European scholars and many of them were actually Jesuit priests. They used to come, and they are those ancient days time. When telescopic astronomy started taking place, and they used to bring telescopes and do astronomical observation. One major objective was to study the transit of Venus. The transit of Venus is that when at certain time the Venus planet crosses the sun's disk, and if that is observed and the timing is done accurately, that can give more accurate distance of sun from the earth. Otherwise, it is an indirect determination. So, for that purpose, this even today, scientists and astronomers they take this event as very important one. In recent times, there was one transit. It will be another maybe few hundred later years, not now. So there, and the Europe sky is most of the time covered in cloud, as you all know. So therefore, to get a clearer sky and better observation facilities, they used to come. Originally, their objective is to come to Pondicherry, which was under the French rule at that time. And also, some of these priests went to Thailand or Sham, where something happened. The first hint of astronomical knowledge in ancient India was found in an incomplete manuscript brought from Siam or Thailand by L.A. Lowbray in the year 1687. Actually, this group of scholars, they went to Thailand and they were trying to do the kind of teaching, etc., or other dissemination of their astronomical knowledge, actually. But there was a coup, and so they had to flee the palace because they are housed in the palace of the king or emperor. So they had to flee and they came to Pondicherry, really. And while coming, they brought some manuscripts which are not complete, but in hurry they had to leave. And it contained tables and rules for calculating the positions of the sun and the moon. You know, actually, that was the important thing in ancient. Planets became important at a later time. Sun and moon was the most important thing, and these tables contain the positions of the sun and the moon, how to calculate. Now later, Cassini was another famous astronomer of that time. He studied these tables and showed that it was required to subtract 3 minutes from the sun's position and 40 minutes from the moon's position, estimated using the tables, it implying that the reference meridian was 18 degrees west of Siam, that is India. That means whenever you do a table, you need a reference. Now our reference meridian is Greenwich. But here, the reference which was used, if you consider that to be Thailand, then you find you need to do these corrections in the positions which you get from the table. But if you consider the reference line about 18 degrees west of Sham, that is Thailand, then it matches, the results are accurate. Now, but 18 degrees west of Sham is actually India. It is, I think, Varanasi approximately. Later, some more elaborate tables were found to exist in India, and the real beginning was when La Gentile returned from India in 1769 after observing a transit of Venus at Pondicherry with amazing experience about the capabilities of Indian Pandits in astronomical calculation. Now, I'll tell that next. So, actually, the first hint was when these Jesuit priests came, they had to flee actually because of a military coup in Siam, but they brought some incomplete manuscript to India. And Cassidy was amazed to see that it gives reasonably correct positions of the sun and the moon if you make these corrections. That means that the reference meridian was 18 degrees west of Siam, that is India. Later, of course, some more elaborate tables were found to exist in India. So this is what was there. You can see that this is Thailand, and if you come 18 degrees west of Thailand, the meridian is Varanasi. So Varanasi being a major, so actually, the ancient Indian astronomy, the meridian used to be Ujjain. Ujjain used to be considered the meridian. But I think this Varanasi, Ujjain, they are all major places of studies in those days. So therefore, perhaps this particular table gave that. But this was all approximate. But anyhow, it was true that these tables were prepared and evolved in India. That is the first time European scholars got the impression that ancient India had astronomical knowledge. Now, I think similar but more elaborate set of astronomical tables were sent by Father Ducham from Krishnapuram, a town in Karnataka, to the I can't read it, in the year 1750. Now, this is, you can see, about, I think, 78 years after. A similar but more elaborate set of astronomical tables were sent by this. They were all studying whatever knowledge they could get from here and there, they're getting. However, not much happened till Lagentil returned from India in the year 1769 after observing a transit of Venus, as I mentioned. This was a very important event. Now, Lagentil was amazed to observe the rapidity with which the Pandits made the calculations. He narrated an event he experienced himself soon after he arrived in Pondicherry. A person named Nanamudu, now they write they're writing their audition. Nanamudu was most probably Namudri, in my opinion. So, but in his presentation, in his writing, he says that a person named Nanamudu, it doesn't sound like the typical South Indian name, so it could be Nambudri. Such confusions are prevalent among the Western scholars. He demonstrated amazing skills in astronomical calculations. Lagentil wanted to examine him and gave an assignment to him to calculate some eclipses, that predict these eclipses, find the time, etc., or even some past eclipses. So sitting on the floor, Nanamudu started his work using some shells, আমরা যাকে কড়ি বলি, and used in place of coins in those days, and a book of palm leaves. ওই আমাদের পুঁথি যেগুলো বলি, তালপত্রের পুঁথি, সেটা নিয়ে ও মাটিতে বসে খড়ি দিয়ে আঁক করছে আর কড়ি দিয়ে he gave the results including the details of the different phases of the eclipse, and the whole process took less than 45 minutes, and Lagentil found, to his utter surprise, the results were sufficiently accurate, but he noticed that Nanamudu had hardly any formal education worth mentioning. So he was not having any formal education, but the results he found in 45 minutes, and the results were quite accurate. So he was absolutely amazed. So he was also, when he was examining or questioned or discussion took place, he was also unaware of the basic principles on which his tables and rules were based upon. But he used those tables and rules blind. Since that time, a considerable amount of interest got generated among the European scholars and the subject. So they realized there must have been some lost knowledge. Otherwise, how such accurate calculations? Following Lagentil's explanation attracted the attention of J.S. Bailey. He was also a famous astronomer of Europe. He was highly impressed by the astronomical knowledge of ancient astronomers of India. He analyzed the tables and placed the period of the preparation of these tables around 3102 BCE. Can you see? He studied those periods, the table, and after analyzing them, he said that they must have been prepared around 3102 BC. You can see almost 5,000 years ago. In 1787, he published his book, Traité de l'Astronomie Indienne et Orientale. He accepted the prevalent idea of the very antiquity of the origin of ancient Indian astronomy. He also believed that the origin of astronomy was indigenous to India. This work of Bailey attracted the attention of many European scholars, including Laplace and Playfair. Laplace, you are all familiar, you know, and Playfair also was very important. Now, Laplace and Playfair analyzed the tables again, which was brought to Europe, and showed that the claimed position of the star Aldebaran in the year 3102 BC by the Indian astronomers was correct based on modern astronomical knowledge. Aldebaran is Rohini. That star is the name of Aldebaran is Rohini star. And it was an important star for various purposes. As even today, Rohini Nakshatra is important, particularly in the village areas. If you go before cultivation, what has to be done in paddy. Paddy, you don't just throw, I think, yes, and then you grow rice. It is not that. No, what is done? There is a transplant. হ্যাঁ মানে কি বলে প্রথমে বীজেতে ধান করে you get the saplings kind of thing, and they are transplanted for the final um, plants which yield the rice. Now this whole process, it is very important that timing of this particular activity of our paddy cultivation, it is very important. That's called, you have to do it around Rohini Nakshatra. Rohini Nakshatra ধানের বীজ বপন করা হয়। তো এই সমস্ত ব্যাপারে there are, I think, various important uses over there. Even today, Rohini Nakshatra was therefore a very important star whose position, etc., was studied even in the ancient times. And as you can see, that it was pretty accurate. Now, the experience of Lagentil attracted the attention of Bailey, Laplace, and Playfair. And Bailey's book, as I mentioned previously, Trade de la Astronomy Indienne et Orientale, was published in 1787, and Laplace and Playfair agreed with Bailey's findings that the table were prepared around 3102 BCE. In 1789, Samuel Davis came out with a good analysis of the Surya Siddhanta. Now, Surya Siddhanta, of course, is a text, very important text of the Siddhantic period, not pre-Siddhantic period. He was quickly followed by Sir William Jones, which you know that he was a judge in Calcutta, Purishni judge in Calcutta High Court. They all agreed with the calculations by the ancient astronomers. However, there was a reversal of attitude by John Bentley in 1799. Now, actually, what is happening, you have to realize, in those days, the biblical doctrine was very firmly engrossed in the mind of all European scholars. According to biblical doctrine, the world got created in 4004 BCE. So any antiquity before that is very difficult for them to accept. So therefore, the attitude which originally they had got changed. A lot of scholars, there are huge hue and cry and Europe and a lot of criticisms, and they're forced to, under the social pressure, to change their opinion. Now, John Bentley, his contention was that neither was Indian astronomy of any significant antiquity, nor was it original. He attempted that. The next period started when they had to abuse ancient Indian knowledge, saying these are all copies, etc., all those things. He attempted to prove that Surya Siddhanta was dated 11th century AD. His writings were marred by derogatory language, contemptuous of anything Indian. Colebrook presented his work in 1807 and 1816 and was of the opinion that Indian astronomy was in some ways indebted to Greek astronomy. Then they started showing that Indian astronomy is an offshoot of Greek astronomy. That is, again, they started showing, So, because, then when they started becoming rulers, the rulers develop an attitude that, anything, or the people or the subjects cannot have something better than the rulers. That psychology, that mental attitude started going. And such antagonistic attitude towards anything of Indian origin was not uncommon among Western scholars. He thought that the Hindu astronomical literature was nothing but a mass of forgeries framed for the purpose of deceiving the world. Now, this is a very ridiculous idea. If you say that in 1,000 years ago, they were enough expert to back calculate something and fudge their data so that in 19th or 18th century astronomers will be baffled, it is ridiculous. If it is done, then it has to be told or assumed, accepted, that their astronomical knowledge was much stronger than what was found from these tables, etc. Anyhow, similar attitude was also noticed in the writings of Whitney. Whitney, if you see I have those books, his preface to that Surya Siddhanta, who thought, quote, from what we know in other respects of the character and tendencies of the Hindu mind, we should not at all look to find Hindus in possession of an astronomical science containing so much of truth. They have been from the very beginning distinguished by a remarkable inaptitude and disinclination to observe, to collect facts, to record, and to make inductive investigation. So you see, that was the really, frankly speaking, I will not blame the European scholars. When they came in 17th, 18th, and 19th century, Indian Hindu society was in such a rotten state. You won't believe, all kinds of superstitions, sati, etc. It was a horribly rotten state. And an European scholar, if it feels that these people, their forefathers, how can they write such, how can they be in possession of such wonderful scientific knowledge, I will not blame them. Because we were in a horrible state. And it happened because of subjugation for 8 centuries. But there is no doubt that our, particularly Hindu society, was in a horrible state. In some respect, even today, I don't consider Hindu society to be good because with this caste system, these divisive policies, and that's why it has been subjugated ages after ages by outsiders. So the Britishers or the European scholars felt that these guys, their forefathers, how can they do it? So it must be either copied or forgery or all kinds of things. That was a reversal of the attitude.
স্যার আজকে এত অব্দি থাক নাকি?
এটা বলেই একটা শেষ করে দিই।
হ্যাঁ, ঠিক আছে, ঠিক
The
আছে।
19th and 20th century, many Western and Indian scholars have worked on ancient Indian astronomy. Some of them are Max Muller, Burgess, Brennan, Weber, Thibot, Jacobi, S.B. Dixit, B. Balgangadhar Tilak, Mukherjee, Shyam Shastri, Sengupta, K. And it can be mentioned here that many studies were facing serious difficulties to match the dates, as the Aryan invasion theory and Max Muller's dating of Rig Veda as 1200 BC were eagerly accepted by the Western scholars. Once the verses of Vedanga Jyotish were reasonably deciphered, we'll discuss those things. It became gradually clear that Indian astronomy should be divided into two major parts. The pre-Siddhantic astronomy started with Rig Veda and ended with Vedanga Jyotish around 1400 BC. And the Siddhantic astronomy started after a long dark period, and that was based on a heliocentric model. No, sorry, geocentric model. But I think based on not nakshatra system, but zodiacal sign based. So I think 4th and 5th century again it started flourishing, and we know we had Aryabhatta and other Brahmagupta, many famous astronomers, which I think. So therefore, now you see this introductory course is not meant to be for experts and professionals, as you can see. So the level will be kept in a very introductory level. However, the understanding of a few basic ideas concerning positional astronomy will be absolutely essential. But even before that, it is desirable to have an understanding of our universe. So the next session onwards will be devoted to brief and rudimentary exposition to the nature of our universe and positional astronomy. So I think I'll stop here today.